Good evening, everyone. Welcome to the 6th lecture of Power System Protection and Switchgear. In this lecture, we are going to study about radial system protection. Radial systems are protected by time delay overcurrent relays, which have adjustable time delays, and the time delay can be set such that the breaker closest to the fault opens while other upstream breakers or other farther breakers with larger time delays remain closed. That is, the relays can be coordinated to operate in sequence so as to interrupt minimum load during faults. We will see an example. So let's draw a figure. This is a generation source, then a transformer. Here we have a breaker B1 connected to a bus. This is bus 1. Then we have a breaker B2 connected to another bus 2. Here we have a load which is L2. Here we have another load which is L1. Then here another breaker is there which is B3, which is connected to another bus which is bus 3, connected to a load L3. Now let's see what happens if a fault occurs here, which is point P1, and in the second case the fault occurs at this point, which is point P2. And this transformer is 345 kV delta bar 34.5 kV star. Okay, so we have loads L1, L2 and L3, buses 1, 2 and 3, breakers B1, B2 and B3, and transformer and a transformer and a source. So we'll see according to the location of the fault how these relays are coordinated, or these overcurrent relays are coordinated with respect to time. Coordination of overcurrent relays usually limits the maximum number of circuit breakers in a radial system to 5 or less. So let's see what happens if the fault happens at point P1. Suppose, let me change the color. Suppose if the fault happens here at point P1, we want only B3 to open, right? We want only B3 to open so that L3 will not be fed, right? L3 will not be supplied, but both L1 and L2 will be supplied. Suppose if B2 also opens, then we will not be able to feed both L2 and L3, but we don't want that to happen, right? So we want B3 only to open, and if B3 fails to open, then after a time delay B2 should open. If B2 opens, both L3 and L2 will not be fed by the source. The connection between L2 and L3 with the source will be disconnected, right? So at present we are we want B3 to disconnect, B3 to open, and load L3 will not be supplied, or load L3 is only interrupted. So we can actually select a longer time delay for the relay at B2, right? Relay corresponding to B2, we can have a time delay with respect to B3, right? With respect to B3, because B3 should operate first. B3 should operate first. For any fault to the right of B3, that means any fault to the right of B3, here, right of B3, it provides, that is B3 provides primary protection, and only if B3 fails to open, B2 opens with a time delay, providing backup protection. So if B3 fails, then B2 will act. This is a backup protection. This is a backup protection. This is a primary protection for all faults to the right side of B3. Okay. Now consider a fault at P2, point P2. Let's see what happens if a fault happens at P2. That is P2, the point P2 is in between B2 and B3. We want B2 to open here. We want B2 to open, right? B2 should open for fault at P2, right? While B1 can remain closed. This can be closed for fault at P2, right? So that here L2 and L3 are interrupted. Both L2 and L3 are interrupted. Since the fault is now closer to the source, because P2 is closer when compared to P1. For a fault at P1, we had the load L2 already fed from the source. So the remaining current will only flow as the fault current, right? I mean that is a path. So if here in this case, as both L2 and L3 are not supplied, or the point of fault is before L2 and L3, we have more fault current. The magnitude of fault current is more compared to the previous fault considered at P1, right? So B2 now opens rapidly because it has sees a higher magnitude of fault current, right? So B2 opens rapidly, whereas it had a larger time delay in the previous case because B2 was a backup protection for fault at P1, right? So B1 can act as a backup protection in this case. B2 was a backup protection for fault at P1, right? Then B2 was a backup protection for fault at P1, right? B1 is a backup protection for fault at P2. Okay, fault at P2. So B2 is a primary protection in this case. B2 is the primary protection for fault at P2. Thus B2 provides primary protection for faults between B2 and B3, but backup protection for faults to the right of B3. Similarly, B1 provides primary protection for faults between B1 and B2, but it acts as a backup protection for further downstream faults, right? That is what. So the coordination time interval is the time interval between the primary and backup protective devices. That is, if one fails, then the backup protection should come into action. So this is what is about radial system protection. We will see a numerical example which will explain all the concepts related to coordination of overcurrent relays for primary and backup protection in radial system protection. Thank you.